We're going to calculate distances to far stars. This example, we're going to calculate the distance to GJ75, otherwise known as HD 10780. Here is an interactive Aladdin Light view, courtesy of Sinbad, and it's a digital sky survey object. This object right here that you see with the crosshairs on it is GJ75. We know the star's apparent magnitude is positive 5.63, and we know the star's absolute magnitude, capital M sub V, is positive 5.63. Apparent magnitude and absolute magnitude are the same. We want to find the distance to this star in units of parsecs. We have a conversion of parsecs to light years. 1 parsec is 3.26 light years should we need it. The equation we're going to use is small m sub v, which is minus big M sub v, is equal to 5 log of d minus 5. Small m sub v is otherwise known as v. So whenever you see a small m, v means the visible band. That means the same thing as just a capital V. We already have that value, 5.63. We know absolute magnitude, capital M sub small v, is 5.63. So we can put this in. So we have 5.63 minus 5.63, and that of course is equal to 0. But that is going to be equal to 5 log d minus 5. So we put that in there. 5 log of d minus 5. So the left-hand side just equals 0. And we're left with 5 log d minus 5. We're going to add 5 to both sides. Of the equation. Carry everything down. We've got 5.63 minus 5.63, which is 0, plus 5, and we end up with a 5 on the left side. We've got a 5 log d minus 5 plus 5, and we're left with a 5 log d. The next step we're going to do is divide both sides of the equation by 5. We're trying to isolate distance on the one side of the equation. So we're going to divide both sides by 5, and we're going to be left with 1 on the left-hand side of the equation. So we have 1 is equal to the log of d. Now log is base 10, so I can just put an artificial 10 here to remind myself. And what this means is we need 10 to the first power will equal d. So I can put 10. Now this number that's over here on the left, which is 1, goes in the superscript, and that is equal to d. So 1 equals log base 10 of d is the same thing as d is equal to 10 to the 1. It's that 10 raised to the exponent here, which is 1, and that is equal to d. So d is equal to 10 to the 1, or 10 parsecs. We know the answer. D is equal to 10 parsecs. And that's how you found it. Now you can easily go in the reverse direction. Let's go ahead and go in the reverse direction. We already know that d is 10 parsecs. What's the log of 10 parsecs? Let's go to our Google calculator and type in log of 10. And we get a value. Log of 10 is 1. So we know this part is 1. Multiply it by 5. So we multiply it by 5. And we have 5 as the answer. So 5 times log of 10 is just 5 minus 5. And we get 0. So we have 0 on the right side, which is equal to 0 on the left side, so long as d is equal to 10 parsecs. So we know that the answer is correct. We have checked it, so I'm going to double box it. 10 parsecs is the distance.